Welcome to 10x Engineering. This podcast is by Urban Company, Asia's biggest platform for home services. We bring beauty, cleaning, or repairs right to your doorstep. This series is by engineers, for engineers, where we'll discuss the fundamentals of building and scaling world-class tech teams. So let's dive in.
Hello, everyone, and welcome to our very first podcast in this series, 10x Engineering. My name is Raghav. I'm the co-founder and CTO at Urban Company, and along with me, I have my close friend and the head of engineering, Kanav Arora, who is often also known as the chief nerd in Urban Company's engineering. We've started this series with the intention of it being by engineers and for engineers, where we will talk about the real principles, the hot debates that happen inside the high growth tech companies. We are going to have leaders from our company, Urban Company, come and talk, have some external leaders kind of come in, bring out their own nuances, bring out their own insights in what does it truly take to create that 10x impact or 10x engineering. So coming to today's topic, kind of both of us are here to introduce the series or introduce the concept of 10x engineering, and let's have a casual chat about it. We've noted down a couple of questions to ground the discussion, but let me start off by asking how did 10x come along? Because I don't know the historical context. Intuitively I know what it means, but I know you've done some bit of research and have context. So how did this all come about?
Absolutely. I think this became a little bit more hotly debated topic maybe in the last year or 2 years. But yeah, you're right. The first time I heard this concept of 10x, I'm like, I've never heard of this. And I feel like I've read a few things. So then I actually went back, and before we even debate, the whole debate is whether there's 10x developers or not, and why startups should be hiring them. And then I went back and said, okay, where does this concept origin from? Where did it come from? And it turns out, so in 1970s, I think they did a bunch of studies. So what they did was they brought a bunch of developers in. They gave them all of them, they gave an individual task. So it was an algorithmically challenging task, so kind of like a coding competition. And what they found out that the ratio of average to best developers, so the best developers were able to do that task in 10x less time. They also used 10x less lines of code, and it was also more performant. And that's where I think the genesis of this, there are some developers who are 10x than others came across, right? But I think this was done at a time where the task was just for one person, and the languages, tooling around it was very archaic, right? It was 1970s we're talking about. But in modern terms, right, the word what is actually 10x has evolved, right? I would like to believe it's not so much to do with inputs. Definitely not inputs. So number of time spent, etc. Hours spent doing the task. It's also definitely not related to output. I think number of lines of code, etc. But I think it's a little bit more related to outcomes and impact. The impact it has in the teams around you, how much you are able to create a multiplier effect for people around you. So it's a little bit more towards impact. So I think that has kind of transformed in this modern world a little bit.
Interesting. I think that's a good take on it. It kind of fits in well with a lot of companies today, where the focus is on outcomes and not outputs, or the focus is on impact and not effort. Right. So what you are defining it as, which resonates well, hopefully with everyone, is what you're really 10xing is the end outcome or the impact, which sounds good. But is it still true? Is the most important ingredient in this 10x impact, is it still the 10x engineer?
So I thought a little bit about it. What I believe is that whole question whether there's a 10x engineer, right, or not. Personally, I think it's inconsequential. This debate does not matter, because you look at from a company's and startups perspective, right? What do they require from their teams or their engineering teams? Is 10x impact or productivity or outcomes, whatever you call it. That is what they require, right? Yeah, and yes, one of the ways to do this, the easiest way you can think about is maybe hire these 10x engineers and build a team around them or build a team of them. But if you read any good computer science textbook, you will realize that if you just bring in a bunch of smart people who you think are 10x and just put them together, it's not true that you are going to get a 10x productivity from a team. It's software engineering is surprisingly a very much a team sport, and I think so. It's not about that 10x developer. Like it's about, and there's a lot more things which actually go to making a team happen and that productivity happen. I think there's a lot more secret ingredients than just hiring really smart people. So that's, I think, what my take is. So I think it doesn't matter whether the
Yeah.
10x developers exist or not.
No, I couldn't agree more. I think hopefully any team which has evolved over time, or anyone who's kind of seen larger teams operate, organically you shift towards more of a team play, right? So in summary, this whole 10x engineering, it's not so much of a myth or not. I mean, I'm sure 10x is absolutely possible and achievable, but it's a rhetoric. Uh, but it's the rhetoric is meant to be 10x impact via the whole team's impact and not an
Absolutely.
individual. And in teams with scale, often the impact of one individual is diminished. So it's a lot more about optimizing for the whole system and not for the individual. I mean, hiring, I'm sure, will be an important ingredient to it. But there's another dimension to this debate, right? Like when I have looked through different examples, another thing which confuses a lot of people is what can I do today to have a 10x leverage also today or tomorrow, right? And it's interesting because 10x is actually a compounding benefit, right? It's slow investments which you will make, right, which will compound probably after 3 years or 5 years. You will see that genuine 10x difference. So I think this is a subtle point which I feel goes underappreciated, right? And people are looking for this mythical 10x, like this magic
Yeah.
sword, but it's actually not. It does come when we get into those topics as well. Like it is hard calls on some interesting things, but it is continuous hard call, and you'll see this impact after a few years. And I think that's what also makes it hard because it's
Yeah.
not tangible right now.
Yeah, absolutely right. I think it requires solid conviction. There are times when I think we have done those things and we realize this could be 10x in the future. We have taken those calls, but it's very hard to know the true impact. But give it a couple of years, like right now, for example, I can easily say, I can even quantify the impact of those calls which we made, and that's enormous. But you can only do it right now. So it takes a little bit of gut call and conviction to do them. But I think that's what a little bit
Yeah.
leadership is also about. So yeah.
It's a lot in hindsight, right? When you kind of
Yeah.
look at, you can almost always look at hindsight and say these were the calls we did them well, and hence we have gotten a 10x
Yeah.
leverage today. Future sight is a little harder. It requires either multiple
Absolutely.
experiences or you learning from other organizations and stuff. So actually, let's go deeper here. I think structuring what 10x is, how do you measure it, makes sense, right? But as an org or as an individual, what are the different levers to actually get this leverage?
Got it. So it's an interesting question. If I to think, I think there are a few factors that are, I think, fairly important, and which go more than just maybe hiring the best developers out there. I think number one, for example, I can think of is work environment, right? Like it requires whether developers are getting, like, how's your workplace environment? What are you taking care of productivity, the tools, the environments for developers to actually be productive, whether that's remote or whether that's in place, right? Like I think giving that sanity of time for developers to actually work to do work, I think that actually compounds fairly well over a period of time.
And some
Um,
small examples would be like things which we've debated, right? Like silence hours at Urban Company, or the example which we keep discussing, the headphone rule, which is a classic
yes,
rule. You know,
yeah, yeah.
talk about that.
Yeah, I think it's super important. Like, I think we used to do this thing. So, a lot of startups, for example, when you're small, you want a lot of communication and you have these open offices, which is amazing. I think it solves for a lot of agility, a lot of easy decision making. But you also realize it also leads to a lot of noise and a lot of meetings that
Yeah.
are, everyone can come and just tap on you. And the way developer minds think is you kind of like inside the chain, and then anytime you get obstructed, you have to go back again. So we used to do these like silence, like library hours in the office for 3 hours, and that's dedicated time where no one's supposed to talk to each other. It's completely silent in the floor, and people get like solid productivity time. So yeah, that was pretty good.
Like
Um,
the time
yeah,
of the cost of context switching, right? Like
yeah,
the brain does not spend time or effort linearly. If you context switch, you have to start again in your focus.
absolutely, absolutely. Coming back to it, I think in terms of what's important for teams to be 10x, like the workplace environment is one. Of course, hiring solid developers goes without. I mean, you have to have smart, opinionated folks, even more so at leadership level. Like, are your leaders in engineering, how technical they are? That's very, very important, because that's when they can actually easily do the trade-offs, right? And based on
Yeah.
their experiences. But even more than hiring, for example, I would think teaching is very important, because imagine you have this, like, okay, you can bring all these smart developers, but imagine you have these code bases spanning across 5 to 10 years. There's so much legacy, there's so much business context. How do you, like, you can get a smart developer, but he will be completely unproductive, like, so how do you onboard that person? How do you institutionalize quality across the board? I think some startups and companies really value it, and you see that compounding effect of it, because you're able to get people to be really productive and in sync with everything. Other things, I think team structuring plays a huge role. I think there's enough science which is put in, which says, your code base, your the way you divide your code is exactly how you divide your teams, and they go parallel, right? So imagine, like, I think the way you divide your teams, what problems are they solving, are they full stack teams or not, like, I think that plays a huge role, because that basically determines how your code will look, pretty much. So I think that's pretty important. And then I think another big leverage is probably like platforms, right? Like, and the ability to build these platforms not only to solve some tech problems, but also how business is configured on these on these platforms. I think this helps reduce the complexity for all these other teams, moves it in one place, and then you can really focus and solve it one place for everyone else, and that gives the 10x boost for all these teams. So yeah, I think these are probably the reasons I can think of. Yeah.
No, I really like the last one. I think it's a hot favorite. I know the teams here we have at Urban Company Engineering. We are fairly fascinated and proud of the platforms we build, and I think actually let me try even structuring why platformization helps. This is weird.
Yeah.
It's a weird word. It's a very technical sounding word, right? I think in any company building process, be it a team, business, whatever. The construct of codification is very important. You learn how to do things well, right? And at some level, you want to codify it, right? And for me, a tech company is basically the perfect company for codification, because code is the best codification, right? So I think it's at platformization at the heart of a lot of tech plays, and I think it broadly structures into two parts, right? Platformization, one part of platformization is the art of breaking problem statements down, right? And you want to break them down because you are trying to define responsibility really sharply and well. And the second part is, how much do you want to codify and how much do you want to keep open-ended? How much of an opinion do you want to come in with? Right? And I think these two factors dictate how teams choose, or how leadership gives the focus opportunities to a team, right? And we see these examples across the board. We've seen teams in companies be split by capabilities. This is a platformization concept, right? We see this in tech as well, where whatever we want to codify, what's so well known, you'll put a code around it. Even in technology teams, you'll have platform teams which are codifying engineering practices, right? Our code is another example where we do a lot of platformization. And there are two very popular principles also, which we talk about, right? You have the single responsibility principle, which is the art of breaking problems the right way so that you optimize on singular responsibility and so on and so forth. And then there's another, my favorite is the open closed principle, right? Open for extension, closed for modification. Basically at the heart of it, it's a trade-off. You want to be very fast with something, so you create a lot of leverage, but you make it hard to do other things which you think are not important to spend time on. So I think at the heart of platformization sits these two dimensions of breaking problems, and there's an art there, and how much do you want to codify and how much you want to take the trade-off. But just to make it more real, Kanav, like what would be some typical examples of platformization in tech?
Yeah. So let's look at, like, I think, where does a developer spend his time? Like, just talking about an engineer, for example. So he has to be responsible for, first of all, writing code. I think there's enough languages out there which actually help you write code. So that's kind of, things exist. Then he has to deploy the code on servers. At some point, 10 years back, like, there was a team of dedicated developers or DevOps. They would basically deploy on your own infrastructure, on your own private infrastructure. And now you look at it, there's AWS, there's GCP, and that's basically your DevOps, right? Like, you don't need to worry about how it's going to scale, how many machines you need. So that part is fairly well platformized. Even things like, for example, monitoring. When the code goes into production, the person has to monitor, debug, logging, alerting. All of these, I think there are a bunch of tools which are already in place. CI/CD, the whole release management, and then there are probably, like, some things which are, which are not very well platformized, are in the gray area. Things like how to institutionalize quality of code. Can you do automatic alerting based on, and all of these things, I think, are there. But uh, if I think about it, right, like, these things are fairly well popular. Like everyone knows about it. Everyone knows you need to do them.
Yeah.
But still, like, there are some teams which are potentially, like, what I've not understood is, like, there are some teams which are still 10x, right? Like, are better than other teams. And if all of this information is available, so then what is the difference still between these teams? Because all of this information is there, right? Like, so yeah.
Yeah, and that's a very valid question, right? We have all these tools, and I think the industry is doing a better job at codifying and platformization. But what about the teams and companies which are at the frontier of this innovation, right? And what's the secret ingredient for them to do it much better? The 10x leverage, and I think very valid question. I think for me, it kind of splits into probably two factors, which at least I've seen happen through urban companies' engineering journey. And actually, they're very simple concepts. So the magic here is not the concept, but the beauty of actually doing these. I think one is the question of timing, right? One is the question of timing, and the other is the question of the decisiveness of leadership, right? For example, the how much of adoption do you have for some of these levers, right? And let me talk about each of them maybe a little bit. Like, timing is a very classic question. I've seen people debate till the cows come home. Hey, don't do it too early. You're over engineering. We all know that, right? But the counter is, let's not wait too much because there'll be technical debt. But here's the interesting thing. I've actually not seen in good companies. I've hardly seen examples of being too early. You always create technical debt, and it's a running treadmill. You are always adding more debt than you're removing, right? And it begs the question of, are you timing it a little later, right? And it brings the question of foresight, right? I think the true 10x teams would have the foresight to time it so well that you actually create very minimal technical debt, right? It's a compounding thing. If you fundamentally believe in the compounding power of 10xing, then timing will play a large role on it.
Yeah. No, absolutely right. Like, I also believe, I think, now come to think of it, I think timing is so important, right? Like, you time it like a few years later, or you don't do those things before later, it can actually compound, or you do a few things earlier. It's usually compounding. Like, I think, for example, I can think, I think 2-3 years back, we realized, there are some product managers, some developers, in the localized way they were doing, experimentation and on features, A/B testing,
Yeah.
all of that. And that's the time I think we stepped in early and said, let's create a central platform for experimentation. So we basically got, like, this one platform where anyone can just go on a dashboard and easily configure experiments. Metrics are all standardized. You automatically get to know, like, some top metrics, how are they moving with each experiment. And what we realized is, like, over a period of time, like, what we saw, every 6 months, the number of running experiments is doubling, right, on this. And now, if I imagine and think about it, imagine all of this was in code, or all of this was like debt. It was crazy, right? Like, and it opened up new avenues also, right? For example, we wanted to migrate some of our APIs, or refactor some of the APIs. We just use this experimentation, and then developer would just go on a dashboard and easily configure how much traffic he wants to move to the other API, and then be able to say whether it's working or not. And now that I imagine, like, okay, at that time we thought we were taking this call early, but imagine in these 2 years, this much productivity, we would have completely lost, or we would completely not opened this avenue. But it also works like, the funny thing is, it also works conversely, also inversely also. So for example, like I think, and that's what people call tech debt, right? Like, and we could kind of measure it. There was a time I think we wanted to refactor one of our services. I think you're very well aware of which service I'm talking about. And we took that call, okay, let's do it a little bit later, like for some reason, whatever, bandwidth, etc. We said, let's do it 1 year later. And then 1 year later, which we found out was the number of services that depended on this service doubled. So what that meant is, because we took that call a little bit later, now suddenly the amount of time it takes to address that debt has definitely doubled. Like it was beautiful. Like it's in a way it's very hauntingly beautiful. But it's, yeah, timing is super critical, and that's why, like, one of our mottos in UC engineering happens to be, if you don't have the time to do it right the first time, when will you have the time to do it over? So yeah, definitely, I think it kind of makes sense now.
Yeah, and even how people get the timing right comes from a sharp opinion and foresight, right? It's not a question of just doing everything early, because then probably you're making a lot of bad calls. It is a question of, folks, especially leadership in much younger days, deciding or having the foresight to be able to call out where technical debt will be there. In fact, some of the best, most impressive leaders in engineering I've been a fan of are actually really good at modeling technical debt. Like, they can give you hard quantifications 2-3 years down on, hey, this is going to be bad, hence we need to do it well today onwards, right? And teams which struggle with technical debt are really bad at, like, modeling 2 years out kya hoega.
Yeah.
What about decisiveness? I think this is also an interesting factor, right? I think there's this whole question of maintenance. Now, in any engineering team, it's a constant churn of things getting old, and there's a constant cycle of repair, right, and improvement. And then there's this whole question of maintenance, right? And at least what I've seen is there's this whole powerful, the ability to have 100% adoption by a lever across your team adds a significant boost to your productivity, right? I think, and the easiest way to kind of describe that is a good to have versus a guarantee, right? 90% of teams doing one stack, and 10% of teams using another older stack, right? While in team structuring, this 90-10 seems like a pretty good trade-off. But if you look at your common teams, right, for example, a platform team, a DevOps team, they still have to do 2x the effort. That 90-10 principle, Pareto, doesn't apply to them. They have to still support the full spectrum of things to be maintained. Have you seen some of this in the past? Do you think adoption has played an important role?
Yeah, absolutely. Like, I think we have seen things in the past where we've kind of figured out that there's a tech debt. We need to have a platform way to solving it. Multiple teams are doing it, so let's kind of platformize it, solve it. But then building a platform is just one part, right? Adopting it in all of this is the other part. And I've seen, like, when you just kind of let it go, when you don't say, okay, I'm just going to create a platform and adoption will happen at some point in the future, it just keeps on increasing, right? Like, the debt keeps on adding because you still have to maintain the other side of things, right? Like, for example, forget even platforms, right? Even if you talk about at the code level. So if I have something which I write, if some statement is true, write some piece of code, and I obviously have to handle the else part of it, right? Now, let's say 98% of the times is the true part happens. But the else code still exists, right? Like, you still have to compile it. If you're refactoring it, you still have to take care of it. If there's a bug that happens, you still have to fix on it. So while you can say 98% people are just going over there, but for a developer, it's still 2x the time. It's not 98 and 2% more. That doesn't work. So, I mean, when it happens at a very low level, it also happens at a very high level. I think a lot of the basics just come from pretty much low level code. So yeah, I think definitely pushing teams for 100. Once you know that there's a platform that's going all guns blazing to get it 100% adopted, I think is very important.
That DNA to go for the kill, I've seen be very important, right? And I think a lot of theory goes around, like, why hiring is important. For me, the real leverage which good quality folks create is actually this opinion on where to kill and where not to kill, right? It's how quickly can you identify a bet as a killer bet, step in early. Once you kind of get convinced, you actually go for the 100% adoption. The debate on keeping everything open-ended and customizable because God knows what the future is. While this is a justifiable stance, this will not lead to that 10x killing thing. Great, Kanav. I think fantastic chat. It's a wrap. I think, in summary, what we are saying is that 10x is absolutely possible. But what you're trying to 10x is the impact, the net impact for the company, for the engineering as an org. Right? It's about the team, not the individual. Individual is just a small part of this. There are a lot of other things. One of our favorite parts in 10xing has been platforms. And every company will have a certain different ideology. But what we've seen is platforms triumph over guidelines because platforms guarantee. Guidelines are just a soft push nudge, right? And that creates that extra leverage a lot. And the two most important factors which we've seen to play well with is the question of timing things early and going for the kill, going for that 100% adoption. And that comes from the foresight, the opinion of engineers, the leaders. So yeah, that's a wrap. Great discussion on this. I think this anchors our upcoming podcasts where we'll probably look at, we should probably go deeper into some of these individual concepts, right? For example, the construct of how do you decide the best stack for a company, right? Is it multiple stacks? Is it one stack? We'll kind of debate out the perfect language. Does it matter? Does it not matter? I know we are a Node.js shop and we are very proud Node.js TypeScript, engineers, right? And I think worthy a debate on is there an ideal stack or not, right? There's this whole concept on teams. What's the right way to evolve teams, structure teams, the trade-offs. I think every choice you make comes with a trade-off. So let's look at these in the coming up podcasts we have. But yeah, thanks. And see you next time.
Yep. All right.